Okay, as I said, the world of hemp is full of authentic characters. I'd like to now introduce you to another authentic character, Wolf Jordan.
You say 1, 2, 3, please.
1, 2, 3, 4, 5, 6.
You have to switch it on. Turn it on, please.
I got it in my pocket. Literally.
I just wanted to make sure you can count to 3.
1, 2, 3. Ladies and gentlemen. Thank you, Steve, for your enormous work you do. Yeah. My name is Wolf Jordan. I am in natural building for some 40 years now. And I'm in building with hemp since 2004 when I read that you could use hemp. No, this does not work.
It works.
Oh yeah, okay, yeah. So I'm going to talk about building with hemp because the hemp industry is taking apparently an enormous explosive expansion, and the more hemp is grown and the more hemp is used, the more we will have the waste of the hemp, which is which are the fiber, the sheaves, the wooden part of the stem. So when you take out the fibers, then the rest of the stem is broken into small pieces. And when you mix this with a binder, you get a wonderful, incredible building thing. So, well, we are at the edge now of a big change in the whole world. Our economy has to change. So the ever-growing and fossil fuel-based economy has to prove to destroy the whole planet. Well, not destroy the whole planet, because when the planet would get lost of humanity, she will recover. We don't need to save the planet, we need to save humanity, you know. And there is so much possible with hemp. And if you go to the Club of Rome, for instance, already in 72, which is quite some time ago, they are warning against the impossibility of an economy that will continue to grow. And in Europe, for instance, 40% of the final energy consumption appears to go to the heating of buildings. So if you build with hemp, this is a classical example of Adnams, one of the biggest beer storing companies in Britain. And at one of Steve's famous symposia, I learned from the people who did this that normally for such a building, the cooling and heating installation would have cost 400,000 British pounds, which is quite a huge lot of money, with an annual consumption of 90,000 pounds a year. Correct me if I remember this wrong, but yeah. Now, they built it from a hemp lime mixture, and there is no heating, nothing at all, and there is no cooling either. There is a constant temperature inside the building, so the annual consumption of 90,000 pounds a year was also Marks and Spencer, for instance. They all also build one of their things with hemp, with precast elements and they casted them up in situ and then put it in the building. So, I mean, it's a serious thing, but you can also do this in simple ways. And this is something I heard about huge and gigantic projects. So hemp has the opportunity and the capacity of being applied on a really large, big scale. But what I am mainly, or maybe even more interested in, not only for Europe, but maybe especially for Asia, is the potential of doing this in a real, incredibly small scale. You know? Because when you build with it, one of the most important things is that in ecological building, a natural building, we want buildings that can breathe. Our skin is a breathing thing. Our clothes need to breathe too. And I can give a bloody simple example. You don't need a university or engineering degree to understand that. Take a big plastic sack bag and put three holes in it. Put it over your head and your arms and run around the block. Then you know what it means that something does not breathe. You will sweat. Now, this is my experience of working with the natural paints and stuff like that. So the synthetic, the normal paint people, they will proclaim, yeah, but we made this, we give our synthetic plastic paints a microporosity. Yeah, they make little holes in it now. I suggest you take this same plastic bag, put a lot of holes in it, wear it again, run the same block, it will give no fucking difference, you know, it's just exactly the same, you will sweat to death, you know. So this is not a breathable thing. In modern building regulations in Europe, we are now forced to build houses with more insulation. Usually people did not build with insulation or not much insulation. We are forced to do this now. And then we create we create a little bit of problem, which is the breathability and the down thing. Maybe first I'll go follow this here. If you want to make hempcrete, this is a mixture, and then you have simple physical laws. Before I did natural paints, when I stepped into my father's business, this was building machines, stuff like that. So I am quite aware how you make the normal concrete, and this technology is quite familiar to me too. And while I'm speaking of the 1973-74, I was already with that. So that's physics. Eh? So you have what is concrete. It's a mixture of fillers, and for fillers it is very important to have a good granulometric composition, which means if your fillers have all the same dimensions. I usually give an example with marbles, but I found it a little bit problematic to travel that far with 2 bags of marbles. So you need. Is it? No, it doesn't work. Well, never mind. You see, you need bigger parts, but the holes between those parts need to be filled up by smaller, and still smaller in between, still smaller in between. You know, that's a safe line. this is quite a normal thing in normal mixtures. Now I would love to go to the next one. Yeah, it's okay.
Slide the next one.
Yeah, okay, no
You
problem.
can do that. You can slide it next one.
Oh yeah? How?
No, it's not.
Oh. Oh no, that's no the one back. Yeah. Now, those fillers. So in concrete, it is pebbles and sand, you know, in a specific granulometric composition. In hempcrete, we love to add as a binder, for instance, clay-based earth materials like loam and cob and stuff like that. People love to call it clay, but with pure clay it's impossible to build because it is too sticky and too fine it will swell when wet, and we don't want this. So you have to add sand and a good natural building loam, we used to call it earlier, is a composition of clay and silt and sand in India. This is excellent for hot and dry tropical climates because it has a high thermal mass, which means it can take up heat and store it for quite a long time. But the problem is it has a very poor insulation capacity. But if you have nothing but clay earth, then, well, sometimes you have to be pragmatic and then with what you have, of course. Yeah. Now, a way much better thing, of course, is lime. I will, of course, which is quite logic, not mention cement, because this is not breathable. Lime works in any climate. It has not only a good thermal mass, but also a wonderful insulation capacity. But there's a little bit more than that would. And of course, you need to add water. Now, according to the different mixing and applying systems, you need a little bit more, a little bit less of water. But water is important because the final carbonatation of lime, as I will explain a little bit further, needs CO2, and inside the hemp wall, there is not enough CO2. So it needs to come from the water and the damp passing. So you need, it sounds contradictional, but a little bit more water can make your whole set faster finally. But that's my experience. Yeah. And I love to experiment. I'm not an entrepreneur not a builder, so I'm not have no responsibility for the buildings for third people, so I can play around and take risks and do stupid things, and it's from your mistakes that you can learn the most. Like, wow. So pure clay is a little, it shrinks too much and it will swell. Oh yeah, but you get this, I don't have to repeat this, you will get this and you can read this easily at home. But one of the oldest binds, lime, is one of the best building materials ever. The Romans have perfected the lime technology already. So a certain Vitruvius has written a handbook for building. He wrote this 79 before Jesus Christ. And this is still a work. If you read this, then you understand lime and you know how to build a thing we forgot. And what those guys built 2,000, even more than 2,000 years ago stands until now. So it must be pretty good, isn't it? In India, too, the building with lime was a tradition, and the old historical buildings in India, also in China, are mainly lime-based. And the Romans had because they did not have the technology we have now in our universities, they had a philosophical point of view based on fire, water, air, and earth, the four elements, which is a wonderful thing. So if you take a limestone, and as far as I know, here in Nepal and India and most of those countries should have lots of limestone, isn't it? So this, if you heat the limestone, which is calcium carbonate, CaCO3, and you heat it up to 800-900 degrees, then the stone will be chemically broken, something happens, the crystal water will evaporate, the H2O, but also the CO2, the carbon inside the stone, will evaporate. And then you get what we call the quicklime, which is quite a reactive, pretty dangerous thing to handle. Calcium oxide, CaO, that's the chemical formula. This quicklime now, if you slake it, if you mix it with water, so by burning, the stone loses something like 44% of its mass. It becomes lighter because part of it is gone. It falls into small pieces, which is very practical for transport afterwards. Yeah, there was, I'll tell that later. You add water, and we call this slaking, then the calcium oxide will take up water again, H2O, and will become hydrated lime or calcium hydroxide or slaked lime. In earlier times, people did this with a lot of water, so this became a pasta, a fat lime pudding, which is the best of the best because the molecules will become finer. You get a finer microporosity afterwards. Now they can do this in powder form, which is more practical for transport, of course, because you don't need to transport this excessive water. You can add it just later on the building side. Yeah. So the calcium hydroxide, if you use this as a building material or as a paint or whatever, and it makes contact with the air again, then it will take up again the CO2, which does it work? No. The CO2, which has evaporated during the burning process, will be taken and absorbed again, so the calcium hydroxide will form again, if you add the CO2 to it, will form calcium carbonate again. So, in fact, it becomes the same stone, chemically, as it has been before the whole treatment. Isn't that wonderful that the Romans already understood this? You have earth, you add the fire, and then you get a quicklime. If you add water, the third element, and it starts to cook, and it's quite an impressive thing happening. If you should do it yourself, you could do that on a small scale. If you should do that yourself, please wear protecting clothes, protect your eyes, because you get temperatures up to real boiling water, and you lose your eye and you lose the sight. Yeah. But then, if you add the air again, the fourth element, then you get earth again. So this is a fantastic way of looking at quite a complicated thing. So I love it that we can use techniques which can be understood with a kind of belly feeling, and not only with technical engineers and formulas and machinery, and you don't need to be a scientist to understand that, you know. Yeah. Now, hydraulic versus hydrated, that's another thing, because you remember this, the CO2 escapes. Not all limestones are pure limestones. Most lime is limestone originated in the Jura period, when there were relatively undeep seas. The elements living there died, and this was formed calcium layers, and then with the drifting of the continents, this is pressed together into chalk with a light pressure, or into limestone with a harder pressure, and into marble stones with was even more pressure. So you find Himalaya salt, sea salt, in the Himalaya, because originally it was pushed above, so there must be a lot of limestone around here, and the mountains are high enough, so yeah. But shortly after World War II, then the cement industry made possible to build faster, because cement is another thing. It's also lime-based, but then it has so processed that when you burn it, when there is clay in it, if you want to burn clay into stone, like in pottery, people doing pottery will know that, then you need temperatures up to 2,200, 2,400 degrees. You know? So this means that the burning of cycle of cement demands much more energy. Point one. Then when you add water to the product, then the cement will set by taking up water. This is why we call that a hydraulic reaction. Hydraulic means the setting is with water. This means that this, here it stops. It will not take the CO2 coming out of the stone, and this is why cement is a much more important polluter in building. I think it stands for 51% of the CO2 production which comes from building, which is a huge amount here. So if we could change this into a building with lime, then we could diminish this, and we will have a product which lasts longer, because cement will last only 80, 90 years, whereas buildings with lime, well, look at the Romans, you know, stands 2,000 years and more, so yeah. The hydrated lime is made of pure limestone. We get this full circle. The hydraulic lime is limestone which has been contaminated, so yeah. But what's now the difference, and what's the important, from technical point of view, this is the microporosity. You know? Hydraulic binders, they take water, and this leaves small holes, which we call micropores, with the capillaries and the mini capillaries connected with each other. Those micropores are big enough so that salts contained in the water can crystallize inside those micropore structures. Now, when they dry out, okay, yeah, but salts have the nasty thing, they will suck up humidity. And when they suck up humidity, they will swell, and they will, by this increasing volume, they will destroy a wall. This is why cement layers, for instance, and cement structures will last maximum 80, 90 years. A word like concrete rot exists in the cement industry, but has never existed in lime industry. So this, of course, has an important essential role for the final breathability. When breathability is in a building is important for the following reason. In winter time, we have a hot, we heat our home, it becomes hot. Warm air, the molecules, there is a lot of room between the molecules, so it can contain a lot of humidity. We wash, shower, do dishes, etc., etc., etc. We breathe, so there is a lot of damp inside a warm air, whereas the colder it becomes outside, the drier the cold air becomes. Because the molecules, they shrink, there is not enough room. That's what happens when it rains. An enormous cloud of damp cools down, the air cools, it shrinks, so the water falls down. That's the rain, yeah. Now, in earlier times, the buildings were not insulated because we have a problem when it is hot inside, cold outside, and you have breathable walls, then the damp will be pressed into the walls, and if you insulate, then you will get the damp becoming colder, 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 and then you get a condensation point, so it becomes water. You don't want water in your wall because then you have a kind of constant water cooling. That would be quite stupid, you know. And if you have frost, if you live in if it is in an area where there is frost, then it will be destroyed by the frost. Now, in modern building and European building regulations, they force people to put a damp stopping membrane at the inside, and then with all these synthetic insulation products, they start to insulate the wall, and this they do to avoid this problem of condensation inside the wall. Now, but then you still have your much too high humidity inside, which will cause rot and moisture and well, you don't want that. Yeah. So people are forced to put a forced ventilation system, which costs 6,000, 7,000, up to 8,000 euros, and well, you can buy a lot of hemp for that, you know. Yeah. Because when you build with hemp, strange things will happen. Yeah, breathability is a very, very complicated thing. Important is the speed of absorption and desorption. The capacity of how much moisture something can contain. And hemp sheaves can contain up to 7 times their weight in water. So this is phenomenal, you know. Also the depth, also the place where your hemp is in the wall. Those are all things which are very important. Hydrated lime and hemp sheaves, in my opinion, are the best marriage, the best, yeah. Well, you can read this afterwards. Yeah. Now, if we use the classical, mostly lambda-based calculations on the installation capacity of that used for building materials, then hempcrete will have it will outperform every calculation we know until now. So there is still something in the capacity of hempcrete that we cannot calculate. So it is. I find this very challenging to know that hemp, not to be surprised about, that hemp contains some unknown things happening inside. So yeah. Now, the hempcrete, if you make it with hydraulic binders, well, if you have nothing else, then you should use hydraulic binders. Now, I'm not talking about cement, but I'm talking about a lime which, for a small part has been contaminated with the clay. Then you get what they call hydraulic limes, where a part of the total thing sets with water instead with CO2. Then the micropores are so that the down regulation will partly go into those micropores. Then there are also different opinions on how to work with hempcrete. Some people say when you make a wall, you need a lot of air in between your hemp sheaves, because air has an insulating capacity. Yeah, this is true. But we did it, I did it otherwise and compressed it more as Steve advises to do, to compress it. And if you use pure hydrated lime, we have our thing tested at Bath University, and there they had a strange conclusion that the lambda of our mixture was a dynamic value. Usually in the literature you will find as a lambda, the lambda should be as low as possible. The lambda of hempcrete is considered to be 0.13 to 0.17. Well, if you do it the right way, we go now to 0.07, something like that. Yeah. But with this hydrated lime and well compressed, then we get a dynamic value with 40 degrees. It's 0.06 of it, and then it goes. The colder it becomes. And it's a pity that at Bath University did not go below 10 degrees, but at 10 degrees it's already 0.075, which is a real good value. Now, how would that come? Because of this very fine micropore structure, something special happens. If you use hydrated lime, which is as a binder, which gives walls that can perfectly breathe and have a perfect moisture and damp regulation capacity. The micropores within those hydrated limes are finer than the pore structure in the hemp itself. So then the lime, and I know this, I'm for so many years, 35, 40 years, I'm experienced with lime and lime renders. So with lime you can create finishes and renders that are capable to to pump out humidity from the wall. So it has very special pumping capacity. So the humidity will be sucked up by the lime, but then it will be pumped. It will not go through the wall, but it will be pumped into the hemp shifts. And this gives a phase change, which is a known physical thing to happen. But special on this phase change is that it generates heat. Now, I met guys at a hemp flax reunion where I spoke last year, some young engineers, and they said they measured that this phase change could go up to 4, 5, 6 degrees Celsius, which is very high. 5 minutes up, no, that's not enough, you know? Okay. Now, this could be the element which gives the special performance to, well, you can read this at home after, if you build with hemp and lime, then your building will be carbon negative. Now, most countries are going to ask a carbon tax. When you build with hemp lime, you should get money from the government because you build carbon negative. So everybody should know that. And if the authorities say, no, you have to pay, just refuse to do that. And send them to me and I will try to convince them, yeah. And I will say they have to come and follow some courses and some with Steve or whatever. Well, now for the mixing, this is a nice type of machine. But you can do it with more industrial machines. You can also spray it with spraying machines. This is a German Putzmeister, the company is called, and they have a huge computer thing here with a huge computer, a huge compressor here, huge compressor. And then a mixing compartment. You put your stuff in it, it mixes very fast, and then you draw a handle, and to a tube like this, you can pump it to the first, fourth, fifth stock if you want to. So this is a machine which allows to work in a professional, fast way, clean, everything concentrated, without the need of carrying around with wheelbarrows, which could be a healthy thing to do. Well, okay. For the even bigger projects, you could use a classical. In Britain, they have done it, as far as I know, for a project of 40 houses. They used a truck mixer like that, and they had 8 cubes of. Some farmers do it with a feed mixer. That works too, and you don't even have to clean it thoroughly because the lime is a good thing to be mixed into the food. I still use the simple thing, but then you have to work in another way. Here we do first the water, then the lime, and then the hemp sheaves. You could, if you would do this in a thing like that, then when you put the water first, the water would run out, which is quite logical, because it empties there on the bottom. So then you usually put first the hemp sheaves, then you wet them, and put the water, or at least part of the water, and then the lime, which gives less dust, of course, and then you mix it, So this is a new build in Belgium with a bamboo structure. So for Asia, where bamboo is local. It's the fastest growing plant in the world. Hemp is the second fastest growing plant. So this is a wonderful combination to build up a structure which is very, very elastic and makes the final building super resistant to earthquakes. You know? This is what they did in Belgium, and we can do it in Belgium. Come on, don't tell me. In Thailand and in Indonesia, there are people building with, and then a formwork is filled and compressed, and then this is the final result. This is an earthquake-resistant building in Italy. Yeah, made from hemp line. Yeah, and then rendered so you can't see it from the outside. Of course, it is this is a building in Belgium. It is essential that the final finishes of the hempcrete should be absolutely natural and breathable. If you would finish this with synthetic paints, not breathable, and here's the retrofitting of an old cheese factory, but here the hemp has been finished with earth plaster, which is beautiful too. This is a thing we made in 2 weeks with only volunteers. We closed this here. Also the floors are made from hempcrete with floor heating. This is a garden wall I made a bit experimental. One thing with truss to put on to have a hydraulic lime, and the other half with only hydrated lime, and the pretension that the hydraulic lime would be better is absolutely very nonsense. But I cannot see it, and these are very unfavorable circumstances. And this is the place where we had our last hemp building symposium with Steve. This was an old castle which was inhabitable from moisture because there is standing, the fundaments are standing in water. And it's an old monument, so it could not be treated from the outside, and it should be conserved. So they put an inside render, I think between 15 and 20 centimeters, and it has been converted into an incredibly comfortable building, because hemp is incredibly comfortable, you know. Hemp buildings usually, you see that's the hemp against the walls there, you know. This is a, oh yeah, that one, oh, my sister has found the pictures, yeah. The first experiments of my atelier, my workshop, that must have been in 2004, something like that, yeah. Where we did it in, yeah. Something which is often forgotten, that is, not all people are in the opportunity of building a brand new house. With hemp and hemp lime, we have a possibility of retrofitting, of insulating old existing buildings. You could even transform a ruin or a near ruin with hempcrete in a very simple way. So you can industrialize this and no problem. But a strong point I see in applying inside or outside insulation, or both sides, for existing buildings, because it must have been millions and millions and millions of houses which are under insulated to the actual style of living and the actual regulations. And not only this, what is very particular in a hemp building, the temperature inside is always between 15 and 16 degrees. This is what the beer thing in Adnams in Britain have stated. I think they built it in 2006 or something. I have a client in Switzerland who had a chalet above 1,200 meters. When they arrived in winter time there, on Fridays it was +2, +3 degrees, +4 maximum, and then they started to heat it and it was comfortable, let's say Sunday morning, and in the early afternoon they had to go back down to the valley because the children needed to go to school and stuff like that. I mean, yeah. So he packed it in with hemp and lime for 20 centimeters, something like that. And winter or summer, even with outside temperatures of -20, or with outside temperature +30, the inside temperature is always between 15 and 16 degrees. So if you want to heat from 15 to, let's say, to 20, it's not a problem. Yeah? And another thing we should not forget is that the comfort temperature is measured based on two temperatures: the average temperature of the air plus the average temperature of the wall divided by 2. This means that if your wall could be 2 degrees warmer, you can heat your room temperature 2 degrees less to have the same feeling of comfort. This is very important to realize that. And with hemp you get, with lime you get warmer walls, with earth cop you get warmer walls, but with a combination with limes you get super warm walls. So, and of course the finishes are very important. That's what we do here. Yeah. I think that's it, yeah.
Thank you very much. Well, let me have your microphone.
Okay, it's lunchtime. I please would like to ask, if you need to make a phone call, please leave the room because your neighbors are not disturbed. The lunch is over at the patio. Okay. See you back here in 1 hour.
No questions.
Switch it off.
This I know.
I think you have to put the resource updated file.
Oh, of course, I do.
It is very difficult to understand Australian English. They speak so fast and
Australian English?
yeah.
Who was the Australian?
Yeah. This recent source, Wolf Jordan's source language is so clear. I can understand so well. Is he?
The native speakers tend to speaking too fast for non-native speakers, and they often forget it. And this is something they remember them always to. So. Okay, come.
Wir gehen schön.
Forget that. Inside the pocket.
Yeah, yeah.
Diraj,